We're looking at section 14.7 in Algebra 2, double angle and half angle identity. So once again, we're going over different ways to look at problems, more ways, more techniques. Once again, a lot of depends upon how things are presented within there. Now, under the double angles part of this, notice we have a bunch of different things for cosine of a double angle. So I'm going to highlight this double angle area. It was under our sum and difference ones. If we consider what's happening here, kind of raising this up a little bit for you, you can see that cosine of 2a equals cosine squared a minus sine squared a. Or it could be 1 minus 2 sine squared a, or 2 cosine squared a minus 1. Now do realize a lot of this is coming in for the simple fact of where we have the Pythagorean identity back here of sine squared a plus cosine squared a equals 1. Because of this, we use substitution in there. We can get different modified ones. Sine of a double angle equals 2 sine a cosine a, and tangent of a double angle equals 2 tangent a over 1 minus tangent squared a. So basically what this happens is if we have angles that are doubled, okay, so as we double an angle over, so I have my angle rotating here, then I'm going to double it again. So here's my overall angle. I might not be able to find that exact value, but if we were to take that angle and bring it back down some, I could reference it as a single angle within here. After that, we start talking about half angle identities. So half angle identities is going to be on the bottom of this formula sheet that you have present for you. In this right here, whole bunch of stuff that we're highlighting, once again, because they're all double line. But here we start talking about half angle identities. Okay, so we talk about what if we were to take an angle and divide it by 2? Okay, so basically we're given like 15 degrees, but we say, well, wait, that's 30 divided by 2. Well, we can do cosine of 30 degrees. We know that one. That's root 2 over 2. So we can just substitute it in here. Now, some of this is do notice that there is a plus or minus in front here. Okay, so there is a plus or minus in front here. That is not present, okay? So that is not present in the actual formula. What we have to do is we have to take a look at, I'm just going to circle all these plus or minus right here. So this plus, this plus, this plus, minus right here. Deal with where is that angle at, okay? So where does that angle divided by 2, or theta divided by 2, what quadrant is that in? So please remember, if this angle over here is in quadrant 1, well, that means cosine's positive, sine's positive, tangent's positive. But if we're in quadrant 2 for what's going on here, then cosine's going to be negative, sine's going to be positive, so it's going to be a plus here. Tangent's negative in quadrant 2, so that means that if that a over 2 would be located in quadrant 2, that's what we'd have to reference. So we have to look at what angle is our original angle, or what quadrant, I should say, is our original angle present in, and that's where that plus or minus sign has to come from. So do realize that you are going to have to put these signs on here because they do weight a very importance into this. So let's look at number 10. Okay, so on number 10 it says to use a double angle to solve here. Okay, so on the previous lesson we talked about the sum angles where 120 degrees is 60 degrees plus 60 degrees. Now we could figure out what 120 degrees is. That's one of our nice ones in here. It's asking us once again to apply something just a little bit different. So it tells us to apply the double angle theorem. 120 degrees is 2 times 60 degrees. So that means we're working with a 60-degree angle. So then we can come to one of our formulas. One of my more favorite ones to work with is taking 2 and then going cosine squared of 60 degrees and then minus 1. So I like taking the cosine of the, 2 times cosine squared of my angle that's going to be doubled in here, so that 60 degrees comes here. Now if we were to think about this, if I come to my 60-degree angle, if I think about a 60-degree angle, that's this angle right here, So if I think about my x motion would be 1, my y motion would be root 3, my hypotenuse or my radius out would be 2. Cosine here would be x over r. So we see that we have 2 times 1/2 squared minus 1. So this is 2 times 1/4 minus 1. So that is 1/2 minus 1, which gives us negative 1/2. Okay, so that's how we would apply that double angle theorem. If we go to number 18, 18 says that we have tangent of 15 degrees. Okay, tangent of 15 degrees asks us that we want to use a half angle here. Okay, so if we want to use a half angle, we're going to look at tangent of 30 degrees divided by 2. Okay, now that we have tangent in here, we have a couple different options we could do in here, but do realize a lot of times the cosine, that first one, really comes into play. So looking at the overall formula, we have plus or minus. Okay, so there's a plus or minus in dealing with this. But if I go back here, 15 degrees is in quadrant 1. And tangent is positive in quadrant 1, so I'm just going to use the positive of this. Now please write the positive for the original substitution. That way I know that you're understanding and it wasn't by fluke that you forgot and just didn't write anything with that plus or minus. So now we're going to go the square root of 1 minus cosine of 30 degrees over 1 plus cosine of 30 degrees. So here we get, now we can drop off that plus sign in front because we don't need it. 1 minus cosine of 30 degrees is root 3 over 2. Once again, if we were just a quick comeback, 1 root 3, 2 if we're at that 30 degrees. Once again, cosine is x over r, so root 3 over 2. And then over we have 1 plus root 3 over 2. So on this one here, notice we get the square root. We have 2 minus root 3 over 2 all over 2 plus root 3 over 2. So as a square root, once again multiplied by that reciprocal, that 2 over 2 plus root 3, we get 2 minus root 3 over 2 plus root 3. We're going to have to rationalize this, so 2 minus root 3, 2 minus root 3 is we're going to have to multiply by here. So we get the square root. We have 4 minus 2 root 3. Once again, we got to distribute this all out. And then that negative root 3 times 2, so minus 2 root 3, negative root 3 times negative root 3 would be plus 3. All over, here we have 4 minus 3. Because once again, we get minus 2 root 3 plus 2 root 3, and then root 3 times a negative root 3 would be my minus 3. So we see now that 4 minus 3 is 1. Everything over 1 is 1, so it kind of simplifies itself down. So then we get the square root of 7 minus 4 root 3, and it's a square root of that. And that's how we're going to leave our exact answer. Okay? Sometimes this calculator, it's not going to do this for you. So if you notice what's going to happen here. I take tangent of 15 degrees. I hit equals. It gives me 2 minus root 3. Oh, wait, that's not good. That's not what this answer is stating because we work with it differently. The calculator is going to do the easier way, and the easier way is not to do a half angle identity on this, but it is a little different in there. Okay, so let's look at just a further example on this. Okay, so if we look at number 42. Okay. So on number 42 here, they tell us that cosine of theta equals 3/5. Then they tell us 270 degrees less than theta less than 360 degrees. They tell us to find the exact value for this. Okay, so on 42 they tell us let's find what cosine of 2 theta equals. Okay, well this one is easier than some of the other ones, but what all this information here, so if I just kind of circle this information, what this information means, what this means is that we have something happening in the fourth quadrant. Okay, so we have something happening here. Okay, I'm just going to kind of draw this point out here, where my x motion is 3, my r is 5. Okay, because once again, x over r. So if we were to think about this right here, we would say, well, wait, if this is 3, this is 5, right triangle, this would be our 3, 4, 5 triangle, very common one in here, but that would be a -4 on this one, because it's not truly a triangle, it's a motion. Okay, but once again, we think about the values as that triangle going in here. If we're asked to find cosine of a double angle, well, we could easily find cosine of this angle, sine of this angle. So I'm going to come back to one of my different ones on here. I'm going to use my first one where cosine of a double angle is cosine squared theta minus sine squared theta. Is it the easiest one to use? No, but I'm just going to use it so you can see a different example in this problem. Well, cosine of this right here, once again, was defined by 3/5, so I'm going to take 3/5 and square it, minus, now sine of this one, so sine, it's going to be squared, is -4/5. So what we see here is we see 9/25 minus 16/25. So if we take 9/25 minus 16/25, we get -7/25. And this is what we would do, because we would use this information, we have this triangle drawn, and then now we would work to solve with whatever values we have missing in here. Going to our last problem then is, well, how do we solve within things? We're going to look at number 50. Okay, so on number 50 right here, 50 is a little different here now. They tell us that we have 2 sine 2 theta minus 3 sine theta equals 0. Well, the problem we have now is, as we're looking at this, we have different angles that we're referencing in here. We have a 2 theta, we have a theta. That's different angles. We can't just add these together, the different terms. So what we want to do is we want to use substitution here. Sine of 2 theta is 2 sine theta cosine theta. Okay, so we see that this right here is our sine theta, or I'm sorry, 2 sine theta cosine theta. And then now minus 3 sine theta equals 0. From here we can factor out a sine theta. So if I factor out this sine theta, okay, so that means if I take a sine theta out of this first product right here, I'm left with 4 cosine theta minus 3 then equals 0. So we have sine theta equals 0, or cosine theta is going to equal, once again, 4 cosine theta minus 3 would equal 0. So I'm going to add 3 over, divide by 4, I get 3/4. So now we got to sit here and we're going to try to figure out, well, what are we talking about? Well, on this one right here, if we think back, this one relates really well to our unit circle. Where is our y motion 0? So our y motion is 0 when we're here and when we're here. So we're at these 2 points right here. So that means when we're at 0 degrees and pi degrees. I'm sorry, pi radians. So 0 radians and pi radians. Once again, the answer asked me to solve in radians. On this one, we got 3/4. Well, 3/4 is a little different in here. So if we think about cosine, not thinking about the unit circle on this one, I'm going to think about this as x over r. Okay, so if I were just to draw a circle, okay, so it's a random circle, not a unit circle, we would see that x motion out here would be 3, as that r motion out here would be 4. But because it's here, we could also be down here. Okay, so we don't know which line we are at, but what we do know is both of these points would hold the same cosine value of a 3/4. Okay, so we come and now we're going to take our cosine inverse. We're going to go theta equals cosine inverse of 3/4. Okay, because we want to be in radians, we want to make sure to switch our calculator over to radians. So now I'm going to take my cosine inverse of 3/4. You could either type it as 3/4, just go 3 divided 4. You can put 0.75. Either way, it's going to come up. And we see that theta equals 0.723. Okay. Now, do realize that's this angle here, because cosine inverse is defined in the first and second quadrant as it goes. Sine inverse is this right here. So we have to reference this down here, so that means this comes down as a negative 0.723. So remember, a theta angle or a negative theta angle on cosine hold the same value, thus the theta and the negative theta angle on here. But we want to reference it as positive, so we're going to take that 6.28 minus 0.723. I'm just going to use a 7.2, drop it down to just 2 decimal places, just because I have my 2 decimal places memorized for my 2 pi. So we get 5.56. So we see that we have 4 answers here. 2 are exact and nice. We have 0 and pi. Our other 2 that happen over here are a little bit more ugly, once again, because of the situation in which they are. We have 0.72 and then 5.7 or 5.56 radians for our answers in here based off of our problem. Do realize we solved it the same. The only thing different now is, once again, we had a double angle to start with here, so we had to bring that down to a single angles by substituting in the value of that, or the formula for that double angle, and then broke it up like we did before.